Defying all expectations, Toyota has chosen a path that few could have imagined. Instead of following the trend of total electrification, it has decided to reinvent the combustion engine. While much of the automotive industry is investing heavily in electric vehicles, the Japanese automaker has decided to breathe new life into technologies that many had already considered outdated. According to Toyota's CEO, the new engine promises to shake the foundations of the industry. But this decision was not made on impulse. The company has been defending and improving its combustion engines for years as part of a clear and persistent strategy. The reliability of these engines has always been a competitive differentiator, sustaining Toyota's leadership in the global market. Therefore, continuing to invest in their development makes perfect sense for the brand. The end result? A breakthrough so significant that many consider it even more impactful than the arrival of hybrids, an innovation also led by Toyota, with the launch of the Prius. Can you imagine the absolute importance this technology will have? Well, that's exactly what we'll see in this video, so stay tuned until the end so you don't miss any details. What is Toyota's all-new technology? The technology that has been arousing enormous curiosity and enchanting motorsport enthusiasts is the new generation of hydrogen engines created by Toyota. But be warned, these aren't traditional fuel cell electric vehicles like the Toyota Mirai. What's in development now is something quite different, an internal combustion engine that uses hydrogen as fuel cell. Models, like the Mirai itself, face some major limitations, especially in performance. They tend to be less powerful, heavier, and impractical for everyday use, leaving much to be desired in terms of drivability and real-world efficiency. Even 10 years after the first units were produced, they are still too impractical to be useful. But what we cannot deny is the ecological component that comes with using hydrogen. Since this is the most abundant element in the world and is also completely ecological, it is understandable that Toyota wanted and still wants to develop cars that use it as a propellant. And this is especially interesting now, at a time when lithium-ion batteries tend to generate a lot of controversy in terms of how environmentally friendly they really are, considering how lithium mining poisons the soil and water around the mines. Furthermore, even with the continued development of lithium-ion batteries, the process of recharging them and their range simply leave a lot to be desired. Combining the power of internal combustion engines with the environmentally friendly component of hydrogen would solve all the problems of both technologies. BMW already explored this technology in the late 90s and early 2000s, and it showed a lot of potential even back then. BMW's hydrogen-powered engines, such as the E38 and E65 7 Series, were codenamed BMW Hydrogen 7. They were powered by a heavily modified V12 engine and proved to be quite reliable, achieving high power without being less fuel efficient than the gasoline version. However, the hydrogen infrastructure at the time was non-existent, which is why neither made it past the prototype stage. But thanks to Toyota's efforts with the Mirai, the supply network has grown significantly since then. As a result, Toyota, unlike BMW, now has a real basis to start making its own hydrogen combustion engine, which is exactly what the company is doing. With all this in mind, it's time to take a look at the details of the hydrogen combustion engine and explain. What are the similarities with internal combustion engines? The main point in common between these two technologies is, without a doubt, the use of internal combustion as the basis for their operation. Another relevant factor is that gasoline engines offer an excellent framework for adaptations that make the use of hydrogen as a fuel viable. In fact, many hydrogen-powered engines, especially those developed by Toyota, are based on this modification. Toyota currently has 2 hydrogen engines in its portfolio, each with distinct and specific purposes in their application. The most popular of the two is the turbocharged 1.6-liter 3-cylinder. Yes, the same one found in the GR Yaris and GR Corolla. The engines are so similar that, despite the change in fuel, the hydrogen 1.6-liter is as noisy as its gasoline-powered equivalent. The other engine is Toyota's 5.0-liter V8. derived from the same engine used in the Lexus RCF. This engine, unlike the 1.6-liter that is planned for use in smaller sports cars, is designed as a high-output engine. Toyota plans to use all of this power in its pickup trucks, large SUVs, and SUVs, and even some larger sedans. The best part of all this is the fact that none of these engines lost much power after being converted to hydrogen. Sure, there was a loss, but the difference is negligible to say the least. But in order to achieve these performance figures without sacrificing Toyota's trademark reliability, several crucial changes had to be made. What modifications were made to make the engine work? The 1.6 and 5.0 engines have undergone a series of adaptations to operate safely and efficiently with hydrogen. The most significant change, without a doubt, was to the fuel system. Unlike gasoline, hydrogen is a gas that must be compressed and cooled to a liquid state in order to be stored. This required replacing the conventional system with a new one capable of withstanding much higher pressures, something that traditional systems designed for liquid fuels at room temperature were not designed to handle. These changes mainly include a new fuel pump and new injectors, as well as fuel tanks that are structurally different from normal fuel tanks. They are the same as those used in the Toyota Mirai, which means they are quite large, like LPG gas tanks. The ignition system was also changed to a different solution, using special spark plugs that ignite hydrogen more efficiently compared to the traditional spark ignition system. Additionally, the electronic control system also needed to be replaced to optimize performance and fuel efficiency, allowing the engine to be utilized much better and significantly increasing its durability. However, the biggest changes of all are the structural ones. Although both engines are made from the same base, there have been several changes to their structure, such as a switch to more resistant materials for the valves, cylinder head and head gaskets, as well as the camshafts and crankshaft. These changes were made to mitigate the reactivity that hydrogen is known for and increase the expected engine life. As a result of these extensive modifications, both the 1.6 and 5.0 engines retained most of the performance levels of their gasoline-powered counterparts while being equally fuel efficient. The 1.6 has been tested in a variety of different vehicles, including the Corolla GR, Corolla Cross, and especially the Toyota Yaris GR. The 5.0 is planned for testing in the Land Cruiser, as well as the Toyota Tundra and Sequoia further down the line. However, with great power comes great responsibility, and with great popularity comes a lot of problems. So we must ask, are there any problems with using this technology? Yes, several challenges have been identified, and the main one, without a doubt, is obtaining hydrogen in its pure form. Despite being the most abundant element in the universe, hydrogen is rarely found isolated in nature. Most of the time, it is bound to other elements, forming compounds that need to be processed to release pure hydrogen. Although the idea of extracting it from water seems simple, the reality is quite different. This process involves electrolysis, a complex and expensive technique that requires specific conditions to work properly. This significantly limits where and how hydrogen can be viably produced. As a result, sourcing hydrogen is, at least for now, a fairly expensive endeavor that is unlikely to be profitable. Driving a hydrogen car is currently 14 times more expensive than driving an electric vehicle, which is not something you want to hear when competing with EVs. Not to mention that the electrolysis process requires electricity, which goes against the idea of replacing electric vehicles with something more environmentally friendly. Furthermore, even if you could obtain hydrogen in some other way, there is another problem: storage. Hydrogen is a highly reactive gas, and storing hydrogen is a highly delicate task that requires perfect conditions to be safe. This problem is even more serious when storing hydrogen in a car, as this requires reinforced tanks made especially for this type of use. Since hydrogen is a highly corrosive gas that can, thanks to its structure, easily escape from any space, hydrogen tanks need to be almost bulletproof, which means they are much heavier than normal tanks, and in some cases, even than the batteries of electric cars. This weight reduces the range and performance of hydrogen-powered vehicles, while also making space inside the vehicle much tighter due to the size of the tanks. Furthermore, while access to refueling stations is noticeably better than it used to be in the 2000s, it is still far from being comprehensive and easy to use. Coverage on a daily basis. There are only a few hydrogen refueling points around the world, which makes the fuel unreliable for everyday use. Finally, as we saw before, hydrogen is a highly reactive gas, which means that if it escapes somehow, it could spontaneously combust, which could lead to fatal consequences. But while the hydrogen situation may seem bleak when we focus on these potential problems, Toyota is convinced that it will quickly find solutions to them. How will Toyota deal with these challenges? Since the introduction of its first hydrogen combustion engine, Toyota has not stopped. The company has been intensely dedicated to finding solutions to the challenges associated with this technology. The main one remains the production of hydrogen. To overcome this obstacle, Toyota is investing in expanding the use of hydrogen not only in the automotive sector, but also in various areas of industry and commerce. While this may sound ambitious, the truth is that interest in hydrogen, in all its forms, is growing rapidly on a global scale. Shipbuilders are very excited about switching to hydrogen combustion engines. Modern cities are slowly but surely starting to rely more on hydrogen, as are industries, which have started to use it as a real energy source. And also, as hydrogen usage increases, the price of gas will decrease significantly over time. We are certainly a long way from hydrogen being truly affordable, but as usage increases, we can expect the price to drop exponentially. Of course, we cannot expect hydrogen to be cheaper than electricity. However, it will certainly be much cheaper than gasoline. Furthermore, when it comes to fuel economy, Toyota is doing its best to reduce consumption as much as possible, which would reduce running costs even further. Regarding tanks, if well cared for, they shouldn't cause any headaches. Just carry out periodic maintenance as with any vehicle. Oh, and let's not forget the price. Unlike electric vehicles, which require a long development time to become usable in everyday life, hydrogen combustion engines are just a traditional mechanical device that is quick and cheap to manufacture, making them ideal for mass production. However, even with everything we saw in this video, there is another technology that Toyota is developing that could kickstart a new phase of hydrogen-powered cars. Toyota's new ammonia-powered engine. Toyota has recently begun considering a different approach to making hydrogen safer and more practical to use. Instead of separating it from the compound it is found in, why not use it directly in that form? This line of research led the company to explore ammonia as an alternative propellant. While water seems to be the most obvious source of hydrogen, the extraction process is still technically complex and expensive. Furthermore, as already mentioned, storing pure hydrogen presents serious difficulties. This is precisely where ammonia stands out. Composed of nitrogen and hydrogen, ammonia appears to be a promising intermediate solution. Unlike water, it is flammable and can be used directly in combustion, making it a realistic and efficient option to drive the advancement of hydrogen-powered engines. As ammonia under certain conditions becomes flammable and is rich in hydrogen, it is not necessary to separate the hydrogen from it. This eliminates one of the most complex and expensive parts of the process of using hydrogen as a propellant, not to mention that by not splitting hydrogen, you also eliminate the need to store it so carefully. In other words, another costly process of using hydrogen is completely eliminated from the equation, and you can also say goodbye to big, heavy fuel tanks, as ammonia is much easier to store than hydrogen. What's more, ammonia is also extremely abundant, as it is the most common alkaline gas in the atmosphere. This means it is also exceptionally affordable to purchase, surpassing gasoline and even more so hydrogen in terms of affordability. In addition to all this, ammonia is much more stable than hydrogen, which makes it safer. Unlike hydrogen, which is highly explosive, the only danger associated with ammonia is that it can be inhaled. The storage process is identical to that of LPG gas. Toyota is so excited about this idea that the company has partnered with Chinese auto giant GAC to manufacture its own ammonia-powered engine. Recently, the two companies announced the 2.0 i4 engine that runs on liquid ammonia. After extensive testing, the engine proved to be 10 times more environmentally friendly than its gasoline equivalent. Of course, this does not mean zero emissions. However, this is not the case for fully electric vehicles either, as both manufacturing, batteries and generating electricity for them are extremely polluting processes. Furthermore, ammonia engines are technically hydrogen engines, with only a few differences, most of which can be boiled down to the fuel injection system. Its use will also allow the parallel development of pure hydrogen as a propellant, making this a visionary and future-oriented technology. And speaking of the future, it's time to ask the most important question. Is hydrogen the future? It is still too early to tell, however. There are strong indications that hydrogen is on its way to becoming the fuel of the future. Despite the current difficulties, it is simply undeniable that hydrogen currently has the greatest potential among all other means of fueling vehicles. Despite its shortcomings, hydrogen remains the only way to power zero-emission vehicles, not to mention that it could also, with the development of the infrastructure and technology surrounding it, reach an incredibly low price. Additionally, the electric vehicle industry has received a lot of backlash in recent years as lithium-ion batteries continue to prove inadequate for real-world use, while also being extremely polluting and expensive to produce. As a result, even 10 years after they became popular, electric cars are still an example of useless luxury, with exorbitant prices and limited uses, which is exactly what hydrogen is intended to fix. No one expects hydrogen to become mainstream anytime soon. However, Toyota's insistence on developing it and the remarkable growth of synthetic fuels in recent years, as well as the decline in popularity towards electric vehicles, are factors that suggest that there are many reasons to believe that hydrogen is far from becoming obsolete. One of the most ambitious projects in the world, the planned city, The Line, in Saudi Arabia, also invests in the potential of hydrogen by choosing it as the main energy source for the entire city, and with the development of other hydrogen-based technologies that are now easier to use, such as ammonia-powered engines, the popularity of hydrogen will also passively increase, indirectly boosting its development. Overall, despite the various problems it faces now, we can expect hydrogen to grow to become one of the forces driving humanity in the next decade or two. That's it for today. If you liked it, don't forget to like and subscribe to the channel. Also, comment on your opinion on the subject. We would like to know. Thanks for watching, and see you in the next video.